Section 4.5 is about graphs of sine and cosine. So our objectives, our goals for this lesson are to graph the parent sine and cosine graphs, which we'll talk about immediately right below. Then we're also graph any sine and cosine graph based using the transformations that we already know. So for these sine and cosine graphs, this is what they look like. On one on the upper left is a sine graph, the one on the lower right is a cosine graph. Now, to get a sine graph, let's refer to things on the unit circle. So effectively, we're going to be plugging in angle measures for x, and we're going to get the y values out after we plug it into sine. So if we start at like 0, we plug in 0, the y value at 0 on the unit circle, pardon me, is also 0. If we plug in pi over 6, according to the unit circle, our y value would be at 1/2. If you were to plug in pi over 4, our y value would be, sorry, I jumped to the right one. It'd be root 2 over 2. Pi over 3 would be root 3 over 2, and then pi over 2, or in other words 90 degrees, would be up at y equals 1. So that just kind of shows the first several points there. You can see some other points here. So say, for example, down here at pi, you'll see it's at 0, which if you're thinking about where it is in the unit circle, that's halfway around the unit circle. It's back on the x-axis, so you get a y value of 0. Down here at 3 pi over 2, we're down at -1 at 270 degrees. Then back at 2 pi, we've completed one full circle, and we're going to say it's completed one full wave. Now, when we're talking about the period of a wave, that's just the time it takes to complete the time or the distance it takes to complete the full wave. So the distance to complete a full wave. Or in other words, the distance it takes for it to repeat. Now the range in this one, we've talked about this in a little bit in the past. It goes from -1 to +1. The highest sine you're ever going to get is -1, or sorry, the highest sine you're ever going to get is +1. The lowest sine you're going to get is -1. Similarly, the cosine graph looks a little like it looks pretty similar, except that it's shifted over a little bit. So instead of starting off like over on the sine graph at 0, 0, this one's going to start off at its highest point, at its amplitude. Then it's going to work its way down and complete a full wave again at 2 pi. So it's got the same base period, like starts from here to here, and it completes one full wave. Whereas in the sine wave, starts at 0, 0, goes up, goes down, and completes the full wave over here. Regardless, they have the same range and the same period. Now, to graph some of this stuff, we're going to use some basic things that we used back in Unit 1. So to graph y equals a times the sine of bx minus c, and y equals a times the cosine of bx minus c, we've got the following characteristics. The first thing is the amplitude is the absolute value of a. So the biggest from, like, we're going to call that kind of that midline here, like on this cosine graph, this midline here. The amplitude would be up 1, down 1, or if it's been stretched or compressed, up a, down a. And the period is going to be 2 pi divided by b. So sometimes the period is going to repeat quicker, sometimes the period is going to repeat slower. Now, the left and right endpoints of one cycle interval can be determined by the following equations. You can use bx minus c equals 0, plug the b and the c in and solve for x, and bx minus c equals 2 pi. We'll use that in a little bit. So testing this out, we're going to start off with just a sine graph, and this one's going to keep it pretty similar. Sorry, the words or the typing got a little close together, so I'm just going to read it right as y equals 2 times the sine of x. So with this information, we're going to talk about a couple things. The parent function, again, is the sine of x. The amplitude is from that a value. The a value is the number out front. So it's the absolute value of 2, in other words, just, well, 2. We didn't really need to do that. What that means is it's been vertically stretched by 2. So it used to go up to +1 and down to -1. Now it's going to go up to +2 and -2. Now the b value in this case is the number that's being multiplied by x. The b value is just 1. The period to calculate that is going to be 2 pi divided by 1. So in other words, just 2 pi. So really that part didn't change at all in this one. There's no crazy shifts or stretches and compressions. On a related note, coming up with left and right endpoints for a single wave, I'm going to do the bx minus c equals 0 and bx minus c equals 2 pi. Well, for our equation, b is equal to 1, so it's just really x, and then the c value is 0, so it's really x equals 0 and x equals 2 pi. So for this specific one, we're going to have a beginning of a wave at x equals 0 and an end of a wave at x equals 2 pi. Now going back to the sine graph, our beginning of our wave was at like that kind of that midline. It's on its way up. And then it finishes at 2 pi in kind of the same relative position. We're going to do the same thing here. We're going to have a starting point, and we got to label some axes here. So what I'm going to do to fill this in, I'm going to do every other tick mark is going to represent 1 pi. So this is going to be pi. This one will be 2 pi. This will be 3 pi. And this one will be 4 pi. And then it also asks us to go down to negative pi, so we'll label that there. So again, looking at this interval, we're going from negative pi to 4 pi. So it's going to complete the wave starting at 0, and it's going to end at 2 pi. So between those 2 points, this is going to complete one full wave. Now we know, and I'm just going to draw a very, 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 very rough sketch of this. It's going to go up and down, come back up. That's what happens in a sine graph. Now to be a little bit more specific, halfway between those 2 points, it's going to cross that midline again. So at pi, it's going to cross that midline again. So between here and here, it's going to reach its highest point. Between pi and 2 pi, it's going to reach its lowest point, halfway between those. So again, to replicate that on our graph here, between 0 and 2 pi, it's going to complete one full wave and come back up. So that means it's going to have to cross the x-axis again halfway. Now between, it's going to go again up, down, and back up. And actually, that wasn't too bad. But between 0 and pi, it's going to have to reach its maximum. And it's going to reach its maximum halfway between those 2 points, and it's going to be up at 2. And again, on this scale, you could draw it to a different scale, but on this scale, it reaches all the way up there. And also between pi and 2 pi, it's going to reach its minimum. So if we're using that same scale, I didn't label it, but -1 and -2. So kind of working with this, we're going to go up, down. This is going to be kind of a skinny graph, especially based on our scale. But that's kind of what that sine curve looks like. Now it does ask us to keep this pattern going from -pi to 4 pi. So this pattern just repeats over and over and over. That's what sine and cosine waves do. And also tangent, but we'll get to that later. So that means that from here, from 2 pi, it's going to go up, back down at 3 pi, cross, and down halfway, and touch again back at 4 pi. Now on the left side of the graph, again, it still keeps that pattern going, so it's on its way down here, and it's going to work its way, it's going to work its way down and back up. So it's just going to be that constantly repeating sine wave.